Okay, so good afternoon, everybody, at least to the ones who are in Europe, and welcome to the second keynote of BPM 2020. It is my pleasure today to introduce Rama Akiraju. Rama is, among others, other things, an IBM fellow and a director in the famous IBM's Watson division, where she leads the AI operation team with a mission to scale AI for enterprises. She also leads a very interesting mission on enabling natural, personalized, and compassionate conversation between computers and humans. And besides her interest in business process management, which will be her topic of today, Rama has worked on several topics linked to the broad AI world, such as agent-based decision support systems, electronic marketplaces, and the semantic web services. And she's been named by Forbes as one of the top 20 women in AI research in March 2017. Today, she will tell us how to infuse AI into business processes and will provide a practitioner's perspective on best practices, thus complementing the investigation on the relationship between AI and BPM that has started already on Monday on the AI for BPM workshop at the conference and somehow continued yesterday with the invited talk of Avigal. Before we start, a reminder to the audience. At the end of the presentation, you will be obviously able to ask questions and interact with Rama, either by using the raise hand feature of Zoom or by typing the questions using the QA button that you find at the bottom of the Zoom screen. Please remember not to use the WOA feature for asking questions because we won't be monitoring that. In any case, unless there are serious problems with your connections, I will enable you to unmute your mic. So even if you write your question in the QA panel, you will have the possibility to ask your question directly to Raman. And I really think this is preferable rather than reading your question. So I think that Rama, you can start your presentation and we are looking forward to hear that.
Thank you so much, Kira, and thank you, Manuel, and the BPM organizing committee for inviting me to give a presentation here. This is like coming home to me. I used to be a pretty active participant and contributor in the BPM conference with papers and I went off to do other things in the meantime, but it's always in the context of business processes. So good to be back. And so good morning, good afternoon, good evening to all of you, depending on where you are joining from. So today I thought I would talk about what it takes to infuse AI into business processes, specifically from the perspective of practitioners, as Kira mentioned. And at IBM, the work that I am doing is very closely related to it. So let's get right to it. So I'll specifically talk about the AI opportunity in business process management. I will make two assertions in this talk and we'll go through some examples why I'm making these assertions. The AI opportunity in BPM, I would say primarily includes automation, optimization, and providing decision support to humans who are involved in managing the process. And I would say for AI to work in enterprises, just infusing AI is not sufficient. AI must demonstrate the following attributes and characteristics, and that is, robustness, accuracy, continuously learning ability, explainability, fairness, accountability, consistency, transparency, and security. Now, those are a whole bunch of words, a mouthful. So I coined a mnemonic to make it easy to remember them. They're called RACE, your facts, as in make your facts run fast. We'll talk through some of those things today. So yeah, primarily I would say this is what I'm going to be talking about. Now, let's get started. Just stepping back and looking at how things got started when there was internet boom. And remember that e-commerce era when we all thought it was all about putting up a website for a company online and maybe answering some frequently asked questions and those sort of things with some pretty images. But 2 decades later, we now understand it better that internet and the electronic commerce has significantly revolutionized retail, right? specifically opening up opportunities like direct sales, better lead generation, new digital advertising channels, and self-service customer support. And all of these are enabled by technologies and analytics, such as better logistics management, clickstream analysis, personalization and sentiment analysis, and chatbots and those sort of things. All of these are new set of analytics or analytics that got significantly revolutionized with infusion of new technology, but really with the application of them to retail industry. Now, similarly, if we think about the opportunity here for AI in business processes, I see the following. We have the opportunity to automate the processes, optimize the processes, again, provide decision support, augment human intelligence, which is, you could argue, is a subset of the decision support, personalization, and provide more natural interfaces to interact with the decision makers. And I just listed some of the sample analytics that can power those opportunities. For example, classification, regression, causal reasoning, search and deriving insights through discovery, and sentiment, emotion, tone analysis types of things for powering personalization, and for providing natural interfaces to users interacting with business processes, technologies such as speech, natural language processing, image recognition, and such. So there is quite a bit that we're starting to notice that AI can bring to business processes. Not that it wasn't being applied and that it is something new, but I will talk about some new technologies and new trends that are emerging in the field of AI, and particularly machine learning and natural language processing, that compels us to take a relook at applying AI and how we can leverage these latest technologies to optimize, automate, provide decision support, and all the things that we just talked about. Let's look at AI in consumer domain. We all know this, right? We use this in our day-to-day lives every day. AI is everywhere in our day-to-day lives, from our smartphones to Alexa, Google Homes, to some of the mini robots that we use in our households, such as Roomba, and our watches, cars that we are driving these days, and in many other things, in security and such, in airports. Now we don't travel all that much, but when we come back to it, or when we were, and retail, even in retail with personalization and such, there is quite a bit of it. If you look at AI in enterprises, there is quite a bit already being applied also, right? So it's in, you think about chatbots or online virtual agents that are providing customer support type of things, and in healthcare, in legal research, providing legal assistance to attorneys to prepare for cases, social media monitoring, in financial services management, in terms of loan approval processing, and in terms of trading analytics and those sort of things, and security and contract understanding, in helping process large documents to understand who owes what to whom, when, and those sort of things. Today, I'll focus on this particular one called AI for IT, which is one of the examples of applying AI to business processes. The business process here being IT, the information technology. Every company has a lot of IT, and there are many processes that are part of, in a CIO organization, if you will, that fall under this in IT, right? So I have listed some, and even in this list of IT processes in an enterprise, I will focus and zoom in on one today for the purposes of discussion. So if you look at the overall IT process, there is software development, there is, once you deploy business applications or business processes, managing the incidents that occur, that is, what kinds of issues are occurring in real time, how do we quickly resolve them, repair them, and make sure that they don't recur again. So that's the incident management process in IT. There are others, such as how do you ensure that these IT processes are secure and compliant? And how do you make sure that as you are writing code, you are able to get assistance around vulnerabilities? and security violations that are in the code, so you can fix them right there. Process mining. This is an area that is near and dear to heart, and for the BPM community, I know several of you in the audience, I'm sure, are working in the area of process mining. There is a lot of scope there for AI. AI for deployment. If you look at the software development life cycle during deployment, how do you assess the change risk associated with it and make predictions around it? That's AI in IT process management. And there are several others in that where all of these processes are delivered to users on the edge, applying AI for edge scenarios. So as I said, I'll focus in on AI for incident management to illustrate. To really get into it, let's take a look at a day in the life of an IT operations manager. And an IT operations manager is also in the world of cloud native application development environment is referred to as site reliability engineer, as some of you may know, in short, SRE. So let's take a look at how life would look for an SRE today, let's say, with some of the best of the breed tools that they may have access to in resolving an issue that happens in their environment. And let's then take a look at what we can do with AI to significantly optimize that process that an SRE goes through, even with the best of the breed solutions being accessible to them. All right, so this is a before and after kind of a scenario I will illustrate. I'll first talk about before, as in without any application of AI for IT operations. By that, I mean there are best of the breed tools which may be doing some analytics and some AI, but really nothing that brings it all together. So, all right, so let's step through how the life for an SRE looks like. So imagine Carlos, an IT operations engineer or an SRE at a company, chatbot code team, and is manually observing these different metrics that are coming his way in an attempt to monitor how healthy the system is and what's going on. He has to look at these different tools. Typically, I've just listed some of them. There could be any number of substitutes you can think of for each one of them, for monitoring metrics, for tickets, for logs, and for alerts, and so on. So there are many tools in an environment. Each one is a best of the breed tool in an environment. However, each one of them gives a siloed piece of information and a signal. Metric monitoring system tells you what's going on with your metrics. A ticketing system captures information about past tickets and the current one that you have to update. A log aggregation system is telling you what different application logs are saying at any point in time. And alerting systems like PagerDuty are telling you what alerts are coming in. So on this particular day at 10:11 a.m. on a Friday morning, this happens to be January 10th at the beginning of this year, let's say, Carlos gets this PagerDuty alert saying, there are 3 PagerDuty alerts. And Carlos says, okay, all right, let me go take a look at what's going on here with this particular, some issue that says ingress US South. There is a problem. And that assistant is a chatbot application that it's not running. So Carlos comes here, opens up this PagerDuty tool, and is looking for information. This is how some of those alerts look like, with a lot of cryptic content in them, a lot of descriptions, not a lot of descriptions, but a lot of specific fields. So about 1 minute in, Carlos is digging into this. He got some sense that it's something going on with some gateway system in chatbot, because of which the system went down. And so Carlos is now digging further to go into a log aggregation system and is trying to look for clues to see what happened. So 4 minutes have gone by since the time the first alert came by, and you can see the clock ticking, and his frustration is starting to build up. And of course, the cost associated with this particular system, chatbot system, not being available is building up, because people are now starting to call humans, are being redirected to humans in the chat because the chatbot is down. So here Carlos is digging in a logging system, and he found about 24 minutes in, there is some kind of an error being issued by these logs, and he's starting to look at inside these errors, brought those errors into a Slack channel, basically a collaboration environment in which he's collaborating with his colleagues to say, hey, this error is coming up in one of these components. It appears to be around the same time. What's going on? And more cutting and pasting going on. And now 35 minutes in, more stuff is happening, and Carlos is having conversations and long discussions with his colleagues. And finally, they say, okay, something, let's restart this particular training pod. And when it did that, these 500 errors have appeared to have subsided. That's 40 minutes in. However, about 2 hours later, there is more errors that are popping up, and another SRE says that, hey, this seems to be related to the, seems to be a continuation of the same issue. It's still happening. So there are more people getting involved now. They're starting to dig to see, starting that particular pod didn't really help. So at this point, they created a ticket and said, this is a major incident. Because it's impacting clients, and so they came to the ticketing tool, and that it got created. 2 hours, 25 minutes in. Total frustration because it recurred and hasn't been resolved is going on, is piling up. More digging, more conversations, and now an expert has been brought in. These are all SREs who've been trained in the past 2 months, but now an expert SRE has been brought in, and the expert SRE looks at all the content and says, look, you got to really do this rolling restart, not just starting this one part. They need to be started in a particular order, and that's all tribal knowledge, right? That's in the head of the person. And they go through that, more discussions. 4 hours, 43 minutes in, they were finally able to resolve it. And look at the amount, the cost, about close to 5 hours, 17 minutes, 135K damage. Okay, so that's the situation with the best of the breed tools. Typically, this is what happens in an enterprise. That's the business process of managing the incidents. So now let's take a look at what exactly are the metrics that we measure for this business process, and what is the opportunity for AI? What can we do for it to improve it? And then I'll come back to this same incident with Carlos and see how this whole thing gets resolved with an AI-infused IT operations management solution. So the metrics that we are really looking at are how quickly can we detect an incident when an incident does occur, that is mean time to detect. How quickly can we isolate an incident to a particular point in the topology, that is the application context? How quickly can we diagnose what exactly is happening, that is mean time to know, mean time to diagnose? Then how quickly can we fix it, mean time to repair? And how quickly can we make sure that it does not recur, that is mean time between failures? And that goes back to really fixing the root cause of the problem as opposed to fixing the symptom by just restarting. So these are the metrics that we are after. So we'll come back to those metrics as well. Now let's switch our gears to what is the opportunity? How can IT help? Okay, so I talked about this particular scenario of reactive incident management. That is when an incident occurs, you quickly find out, figure out, fix it, isolate it, diagnose it, repair it, and so on. That's still being reactive. Fine. There is a bunch of AI work that we can do to really help in quickly improving those mean time metrics. Okay, we'll talk through that. However, that is still reactive. Where we want to get to is actually improve the processes in such a way that we don't have to react. That is, these problems don't even happen in the first place. That is, we have to be able to proactively avoid issues from happening. And that's a journey of being able to have AI augment people's processes and help in resolving an incident, to AI leading with some predictions and telling you where bad things might happen ahead of time, even before they happen, so that you have enough reactive time to take care of those issues before they turn into major incidents. And finally, actually give the feedback of where things are going wrong in such a way to the prior processes in software development life cycle, so that these issues don't even happen in the first place. And that's the proactive issue avoidance, where the opportunities for AI to really lead with automation and with as minimal human supervision as possible. So that's the vision we have. So in order for us to do that, we need to really understand the process by which an incident actually occurs, right? So if we look at incidents are some kind of a malfunction, either of a functional requirement or a non-functional requirement. And if we go through the software development lifecycle, we will see which aspects of those things and contribute to it. So let's look at this traditional software development lifecycle. You design, you architect, you code, build, you test, you deploy, you run, monitor. Incident management focuses particularly on this stage, the last stage, right? Where you have gone through the whole process. Now, all you can do is to manage, to make sure that things are running fine. However, if there are problems that were caused by deployment changes or problems that were caused because of very poor test coverage and or vulnerabilities in security and such that got introduced in the coding stage and all, you won't be able to fix them here. The feedback has to come to previous stages. So in any way, we'll talk about some of those things in a bit, but let's take a look at how can we actually better monitor applications at runtime. If we just were to ask that question alone, we have to really look at the data artifacts that get created in a software development lifecycle, right? So I've listed some of them. I won't read them all, but you see that there are many artifacts at design stage, code stage, test stage, deploy, run stage, right, that are getting created. I'll just cite a couple of them. In the case of running and monitoring the application, these are things such as logs, application logs or infrastructure logs or networking logs, metrics, the application topology, the ticket data, alerts, events, and so on. And at deployment time, it's the deployment configurations, the deployment lineage, and in the case of code, it's the Git issue comments and the bill of materials and code images and those sort of things. The key point is that there are several of these are in different formats. They're structured, unstructured, and semi-structured. Some of them, like deployment descriptors, combination of structured and unstructured, logs are semi-structured, chat conversations are fairly unstructured. So the question is, when we want to really take all of these type of data artifacts to as inputs to for analysis, we need to be able to really understand and process the structured, semi-structured, and totally unstructured content. So this brings me back to the point that, okay, enterprise, what is the difference between enterprise data and consumer data? Enterprise data, both of them are complex in their own way, but enterprise data has certain specific characteristics that make it, again, specifically complex, and that makes it also need the domain understanding for AI to solve it. So for example, data, it's not that there is not enough data in an enterprise context to train AI models, but it's more of, you're dying of thirst in an ocean of water scenario where you have plenty of data, but it's not clean, it's complex, it's in different formats, it's not labeled. Data privacy restrictions prevent you from crowdsourcing or labeling that kind of data. It requires multiple language support, and also there is some special vocabulary and terminology and such that's involved in each enterprise and in each industry and domain that makes it that subject matter experts have to be available to teach AI systems what it means when certain vocabulary terms are used in an enterprise. So if you look at this, of the three, structured, semi-structured, and unstructured content, the structured content it's fairly well understood because there has been a large body of work that's been done by the database community, information management community over the past several decades, right? So we understand how to represent schemas, how to manipulate and retrieve and query and all that very well. The opportunity for AI in an enterprise context beyond analyzing structured data lies in really this tapping into this semi-structured and unstructured data that has gotten not much, that hasn't gotten much attention up until now. And that includes things like analyzing chat conversations or analyzing logs, application logs, or ticket data, which is semi-structured or very unstructured. So what are some of the building blocks that we can bring to bear to really tap into that kind of content? That is the opportunity here that I'm talking about, and building the bridge between structured and unstructured data analysis so that we can now get signals and warnings and insights from all of the types of data together to be able to support these IT operations folks and SREs to act quickly. So I'll talk about some of these things. There is speech to text, text to speech, depending on what it is, natural language understanding, and getting deeper into the natural language text, such as the chat conversations to better understand. And if there are any images, charts, graphs, and understanding those, we need technologies, foundational AI technologies for all of them. Okay, so we'll have them. So now I'll take a slight detour to go into the AI part of it, and then I'll come back around to tie it with the IT operations domain. This community is fairly technical, needs no introduction to AI, NLP, ML, DL concepts, right? Just to kind of bring everybody along with me. Broader AI, we all know, is concerned with broader topics like reasoning, knowledge representation, planning, learning, natural language processing, and all of those things. Machine learning is a subset of it. Natural language processing is intersecting with machine learning, but has additional components such as natural language understanding, natural language generation, and so on. And I will leave out automatic speech recognition, text to speech, and vision for the time being. We'll focus more on processing textual data for IT operations environment. So let's look at the latest advancements in AI to see what is it that that the latest AI advancements, what are those that make it possible for us to mine these unstructured, semi-structured content like logs, like chats more effectively now than we were able to do before. So if we look at the natural language understanding scoreboards, where human data, the tasks are defined, where they're labeled by humans, and the ground truth is set up, and different algorithms, people experiment with different algorithms to see how well they can do those tasks, perform those tasks. Tasks here being predicting sentiment or doing machine translation and those sort of things. And certain scores are used, and this is by no means a done deal. There is still a lot more work that needs to be done. But if you look at the latest leader scoreboards, it appears that actually for some of the tasks, if the black line is the human line that captures the efficiency of a human in performing those tasks, the glue scores, the language understanding score for different algorithms is starting to actually surpass, in some cases, I would say, the human ability to do those tasks. Now, so that's an encouragement. So we are able to capture, represent, even though in very siloed, small data set environments, very pre-cooked type of things. It's a great sign, and there is a lot that can be done to leverage these algorithms and advancements to understand natural language data. And this is attributable to language models such as BERT or OpenAPI, GPT, Elmo, FastText, and those sort of things. And similarly, we're also seeing advancements in text-to-speech, speech-to-text, be it the mean opinion score or the word error rate or sentence error rate, where they're performing on par or better than human levels, in very narrowed certain domains. But again, a great encouragement, and shows that we now have the ability to start to tap into the semi-structured and unstructured data. So now I'll come back to this point to say, okay, I'm going to focus on the run before I come back to talking about the opportunity in avoiding incidents from happening. Just look at the incident management data. The data that we are talking about are these logs, metrics, tickets, topology, alerts, events that are coming in, and chats, root cause comments. So what are some things that we can do? Well, If we look at logs and metrics, we can take the data and build anomaly prediction models and predict or detect anomalies as they occur or before they occur. That's an opportunity that helps in diagnosing incidents and in detecting incidents. Now, the second opportunity is, as many incidents come about, how to reduce noise and how to group them into their corresponding incidents so that it's easy for an SRE to manage these hundreds of events, PagerDuty events that are popping up on their phone. The other opportunity is, okay, you found that incidents are, some bad things are happening through anomaly detection, you group them. Now we need to be able to help an SRE understand where the fault is. And that's where, if we derive topologies, application topologies, that the dependency graphs of applications and infrastructure, we will be able to, with entity linking, we'll be able to better localize the fault, where in the topology, which component is the one that's a faulty one, and what is the overall affected component blast radius, that is, which all components get affected because of this, and what is the probable cause for identification. And finally, okay, we've helped diagnose the incident. How do we fix or repair the incident? And that is the incident, mining the past ticket data to identify similar problems and bring about the actions that were taken, the next best actions that can be recommended. So these are all things that we can do to optimize an incident resolution, incident management business process with AI. And what's new, you may ask, is the ability to process logs, parse logs, the ability to identify entities, that is, entities being, what is the name of the server or the application or the component or the pod that is being referenced in the error logs or in the logs, or that's being referenced in that cryptic PagerDuty alert that we have seen, and so on. So there's a lot of this processing semi-structured data to identify those entities. So that's where the entity recognition type of technologies can be applied. Again, in the case of fault localization, it's of course the graph traversal and edge weighted and node weighted graph to say how many signals are corroborating and telling me that this is the component that's at fault. So taking those as weights into account in terms of the number of signals and isolating faults and such. So there are many of these things that are now possible because we can bring about either deep learning models or language models such as BERT or FastText, with which we can train IT operations domain content. So I will just go through some of these things quickly to talk about how we are applying AI to these business processes. And then I'll talk about the other set of concerns that I mentioned about robustness, accuracy, consistency, and all those things. Raise your facts, mnemonic, going back to that. So for logs, you can say that you prepare a model, you first parse the logs, classify the error templates, and there is, for parsing the logs, there is, you need features, and you can prepare the features with language models such as BERT or FastText, and then create a prediction model with statistical ML, could be principal component analysis, could be LSTM, any kind of algorithms, and put your pipeline together. And eventually you can also have different techniques for, when the anomalies are getting predicted at each time interval, how do you aggregate them, and how do you explain the results as to why you call this as an anomaly? What are the features or contributing factors? And that goes a long way. Similarly, algorithms in anomaly prediction from metrics, you could use a variety of them: time series based, multivariate, univariate, Granger causality, to be able to explain where the weird behavior is, and forecasting, linear and nonlinear regression type of things, where if you want to be able to say, hey, what happens if I don't deal with this anomaly? What kind of what if scenarios? And also help me understand exactly which factors are contributing to it. So there, again, different algorithms. And I also want to point out some of the opportunities in with the natural language. So if we look at ticket data, which tends to be fairly unstructured comments that humans write into structured fields, you may see things such as, customers are receiving errors when accessing a particular company's reservation service. And the resolution could be that such and such team, compose team, restarted database process. So when you mine this text, there is a lot of conversation that went on that has been cut and pasted from ticketing tool, from the collaboration tools into the ticketing tool. Eventually, what we are looking for are succinct phrases like this to recommend next best actions. When we go to prior incidents and say, I have ingested all the prior incident content. Now a particular incident is happening at this point in time, and I need to be able to match the symptoms of the current incident with the ones that are in the prior incident database, so that I can find one that matches it, and I can retrieve the action that I can take from it. And the action has to be succinct and crisp. And this action, in fact, eventually can be automated with what is called a runbook, where you set it up and automatically execute the script to run it, right? That's taking it all the way through to automation, as opposed to just stopping at recommendation. But that's the first step of getting there, is to extract this natural language, from this natural language phrases that are important, such as this restarting database. And that's to do with entity linking and entity and action linking, because restarted is the action, and database process is the entity upon which that action is performed. So if in the unstructured field, we want to be able to go and pull these things, even if they're spread out across multiple words in a sentence or across multiple sentences in a conversation, pull it and create a very specific actionable entity, such as this restart a database process. And going further, it could be actually more interesting scenarios will emerge, where sometimes the action that is taken is multi-step process, right? Where you scale up the compose node, you fix a memory error, then you restart and force scale this, and then you restart analytical parts. These things need to be done in a sequence, and that was mentioned in a text typed up by an SRE for a prior incident. And now we need to be able to extract the sequence of it with the temporal aspects being taken into account to create a runbook for automation with the corresponding sequence. And further on, you could even imagine in the ticket data, when a root cause analysis is performed several days later, weeks later, minutes later, hours later, whatever the case may be, that we need to be able to really construct this type of causal graphs that tell us that, hey, this particular problem for which we ended up restarting this container orchestration system was caused by a defect in the automated deployment. So that was the root cause, and just that restarting happens to be a repair action. But in order to really fix it, you got to fix it there. So that means that when we capture all of these kind of relationships and establish these causal links, we can now start to use this information as pre-built content out of the box to quickly resolve an incident. So I wanted to sum up the AI aspects of it. It's about linking the siloed signals, that is, when anomalies, alerts come from different signals, from metrics, logs, from other systems. How do you link them all to say, hey, they're all talking about the same particular component, and because they're being referenced, and I'm able to mine those entities from these different systems using natural language processing, and now I can link them. So I can now piece together a holistic problem context. It's not that I get 100 alerts and I don't know what to do with them. I need to address each one of them, but I'm able to say, out of these 100, there are actually 3 incidents that are happening, and they're really grouped. These 50 incidents, then these 30 incidents, and these 20 incidents each have been grouped into 3 different buckets. And we are now able to tell you exactly, let's say with AI, able to say where is the fault happening, which component, and what action you can take, and what might be the root cause associated with it, and all that, right? So that's the aspect of linking signals and creating a holistic problem context. And then the ability to explain with um, different techniques, right? With linear and linear regression type of things, we understand what features, what attributes contribute to it. In the case of deep learning algorithms, we can use techniques such as LIME to, after the fact, query and piece together which are the prominent features that are contributing to the predictions that it's making and so on. But being able to explain with evidence so that it really gives that understanding to SREs on why we are making the predictions or why we are making the recommendations. And coming back to the previous example that I had shown, where we can actually now, by mining all the prior content and IT domain data, train pre-built type of models out of BERT and create these out-of-the-box models and automate things with rule books, run books that we derive with entity action linking that I had mentioned, not just stop at next best action recommendation, and continuously improve with use of feedback, right? And we'll now talk about the proactive issue avoidance and how we can get to self-aware, self-healing autonomic systems. Because ideally the goal is, in an IT operations environment, you don't just want to stop at incident resolution. You want to really provide that feedback to the software development lifecycle activities so that you can prevent these issues from happening in the first place. So I've been talking for a long time. Kiera or Manuel, can you please just acknowledge once I'm still audible? You can see, hear me all okay, and then I'll go on.
Yeah, everything is okay.
Okay, thank you. All right, so let's move on to say the bigger opportunity here, that is proactive issue avoidance and more AI. And again, just to kind of level set, I'm taking a one example of in the business process called IT operations management, for illustrating the opportunity of AI in business process. And we will come back to elevating this with all of the say across multiple business processes. What is when we abstract it out, what are the higher set of concerns? We'll come back to that in just a minute. So I want to come back to the SRE incident, the scenario that we just went through, where Carlos had to go through this and about 5 hours was spent. So now what will happen? Let's say we now have AI doing log anomaly prediction, metric anomaly prediction, doing event grouping, and doing fault diagnosis, creating this holistic problem context, explaining things better. Let's see how that transpires. So Carlos is now back. Let's turn the time clock back. Carlos is looking at all of the same tools. Again, an incident happens, 10:11. And instead of getting 5 different alerts, Carlos actually gets one saying Watson Assistant or whatever, this particular one is experiencing a problem, the chatbot one. And when Carlos goes into the place where he does work, which is the collaboration environment, chat ops, you may recall that is where all the experts were feverishly working for 5 hours to resolve the problem. Carlos gets a view like this, and this is one of the things that we have built. I mean, I'm just showing the visualizations here. So here, it says here is one incident story. It has several incidents. There are 20 incidents that are part of it. All of them have been grouped. Here is here is the problem. It's been localized to this particular component called runtime. These are all the services that got impacted. And here is the explanation. These are, in this particular case, 4 events. Here is how there is a particular log that is showing this kind of error. By the way, it's not just that I'll stop here. Let me actually go ahead and execute a query to find if there are in the past similar incidents from which we can get recommendations. So far, Carlos had spent 1 minute looking at this. The system has already grouped things and predicted the anomalies. The log anomalies are being shown. And when the search query is executed, it gives the set of top 5 similar incidents. And these phrases have been extracted with natural language understanding to say, scale up and restart, or that these pods were restarted and this issue got resolved. So there is a lot of context. These phrases have been extracted. And at this point, if any of these top 5 symptoms matches what this particular incident is, and if one of the resolution actions is applicable, Carlos can simply execute that manually, or if there is an automated runbook associated with it, just click that acknowledge and run that runbook. So basically, to process this, it may have taken 5-6 minutes, and to run and execute and bring the system back, and more details about recommendations. And in the end, out of this 4 hours 53 minutes, whatever total time from the time it's executed and verified and all that, it could be of the order of 14 minutes or even less. And this is a real example that we had gone through with a real chatbot that has been deployed with incidents and real data. So in this particular case, 5 hours got reduced to 15 minutes. And instead of 10 people getting involved, it's 1 person. Instead of 17 steps getting involved, it's 4 steps. And the amount of cost, of course, is significantly lower. Now I come back to, so now let's take one model, log anomaly model, and start to go through the AI aspects of it. Somebody might ask, what is the accuracy of your log anomaly model? And let's say I gave this answer. The prediction of normal data, from normal data, it's if there is no anomaly, we get it 93% of the time. There are some false positives. If it is abnormal, that is when there are anomalies, we are able to predict it 66% of the time, right? Let's say that's the per class accuracy. Should you accept this response? Well, how do you know what data set has that been tested on? And does that always translate to all data sets? There are so many questions that are not answered, right? So here is more data. Let's say we tested it on multiple data sets. Some are on open domain data sets. Some are on fault injection, simulation, chaos testing type of data sets that we have created. Some are real world data sets from companies. Now we start to test this AI model across various data sets and start to catalog the per class accuracy. So we get a better idea when we take averages to say how well this model behaves. Okay, so now you got this answer saying, it's not just one data set or one number that I'm throwing at you. I'm giving you more context. Should you accept this response for an AI model? And you being, a CIO who is making a purchase of this particular solution, or you are the data scientist in a company who is evaluating how you can apply AI to your business processes. Well, I still haven't given you what that AI model has been tested on. What was it trained on? Sorry, I just gave you what it has been tested on, but I haven't told you what it has been trained on. So if there is unseen data sets, how will it perform is not clear, right? So now let's say I give you more information. I give you, these are all the training logs. This is the things that I tested on. This is the amount that it's been tested on, trained on. And this is unsupervised. That is, all you have to do is to give normal data from your environment that don't have major incidents. And based on that, the system learns what is normal. And again, based on that, it will be able to predict what is not normal because it deviates from what it has learned to be normal. All right. Okay, so now you've given me more information. You've given me what it's been trained on, what it's been tested on, how many data sets we've tested on. Now I've got a better idea of how well this AI model performs. So the question that I'm now trying to answer is, when you put this AI, what are the considerations that you have to take into account? Is it just that, how do we know that it is good enough for us to deploy and trust in production, right? Well, Not enough. Just accuracy is not enough. For AI to work in enterprises, AI must demonstrate not only accuracy, but also it should show that it can continuously learn, that is, take users' feedback and continuously learn, and that it can consistently improve, not just improve when one time around and go back the other time. And it has to be secure. It has to be fair and not biased as we add more content. And I only talked about the IT operations process, but if you broaden it to AI and business processes, we are talking about biases that may get included when you are providing loan lending prediction application. It's taking factors into account that could be biased. You want to make sure that it's fair, right? And how do you make sure that it's explaining its predictions and transparent, and that it's accountable, that I know that from iteration to iteration I have taken this much data and improved it this in this manner, and that it's robust and I have full provenance of it. These are all things that must be accounted for when we build an AI model. So we looked at how AI can help business processes. Great. How advancements in natural language processing, machine learning, BERT, OpenGPT, all these are great advancements that we can now put to use to tap into structured and unstructured content. In addition to the prior structured only, semi-structured and unstructured as well, bring AI to really put the holistic problem, contexts and all, really help improve. Great. Now we got to be able to trust that AI that we put in an enterprise. So these are all the concerns that we have to take in. And when we put all these things together, raise facts, you get the mnemonic. So now let me just quickly talk about some of these things, and I'll leave 5 minutes for questions. Just to kind of, I won't be able to go through all of them in time, but just to go through, understanding human language is hard enough, but for enterprises to understand, when we talk for AI to understand enterprise language, it has to really get into the details at this level, right? This is how logs look, this is how tickets look, this is how operations data look. So how can we really address, without solving the entire broad AI problem? The key insight that we got is that we, instead of solving the full broad AI, have a good foundational base with the language models, but then you can start to narrow the domain with specific IT operations domain data, or financial industry data, or whatever the case may be, and further start to customize it with the client data. So what that gives you is this ability to ride these learning curves and get to the accuracies, precision, recall, metric measures that you want faster with smaller amounts of training data that may or may not require labeling. And the second point for improving accuracy is use language models such as BERT type of fast text type of things, and build on multiple layers so that you can, at different levels of the layers, you can let it perform different tasks and use multitask learning and multilingual learning to help you get to the endpoint faster and do multiple things. So one example here is that we take pre-trained BERT, and on the top layer, using feed-forward neural nets and softmax, bring in specific type of data with specific error messages, types and severities, for example, in the case of log anomaly prediction, and use that pre-trained IT operations BERT data to make anomaly predictions. So coming back and summarizing this, to improve accuracy, you don't have to solve the full broad AI problem. You can only solve the narrow AI problem and build AI models on top of it. And that's just fine. It'll solve the problem at hand quite well. For continuous learning, just the way humans fall, many times before learning to ride a bike, AI systems also have to learn from the mistakes they make. So ensure that you have a disciplined error management process, an error analysis process, where as the model is making predictions, make sure that you're able to take some of them, have an expert label them as correct or incorrect predictions initially, and over time build these observer models that are able to predict whether this prediction made by the AI model is a right or wrong one. So it's sort of like a meta model, and automate the process of continuous improvement as much as possible. That is by taking additional data, and in the areas where the model is weak at, improve the model by retraining it or incrementally training it and redeploying the model. So at any given point in time, every month, every week, every day, depending on the type of AI model, we have to be able to constantly keep on improving it with more data. But with improving it more data and all of this comes with these additional challenges of fairness and bias, because you bring in more data, you don't know what all data you're putting in, and you could be biasing and drifting the model. So you got to be very careful about it. So I will, again, I won't go through all of these things. You know, there's been a lot out in the media in the past few months to the last couple of years where AI systems are discriminating certain uh, races and categories of people in image recognition and in others. And in fact, more recently as 2 months ago, there was an article in New York Times that came out and said, you know, that a person was wrongly accused by an algorithm, and police actually jailed that person incorrectly, and only to realize later that it was they blindly trusted a prediction algorithm. So there are lots of societal complications and issues and implications to not paying attention to the biases that may get introduced in the data or in the way we formulate the goal for an AI model. So all these things have to be carefully, again, monitored, and there are many tools that are available for people at hand these days to debias their data before they feed it into training models and such. So I always say this: when you don't know where you're, I use this quote to say this applies to AI, that when you don't know where you're going, every road will get you there. If you don't set a goal and an objective for an AI model, you don't know what data to prepare, and therefore you cannot guarantee what predictions it makes on what type of data. So you have to be very crystal clear on, I'm building a log anomaly model for predicting, you know, this type of data. If seasonality needs to be taken into account, then of course you have to feed enough data that takes seasonality into account. Otherwise it won't be able to properly do seasonality. So I'll skip some of these things. The transparency, being able to explain, being able to consistently improve is important. You know, you don't necessarily have to always use machine learning. Statistical machine learning models may forget what they learned once, and this can lead to improvements in one iteration and regressions in other iterations. So using rules to bridge the last mile, or to build systems that learn from rules, systems that learn rules from machine learning, and then exposing those rules to the user so that it's all transparent, and users can actually understand what the system is doing, are also some new areas and technologies that are emerging in this space to make it more explainable and bring about explainable AI. And I'll talk about drift and other things at a later time, but I'll just mention it here, saying that if you don't monitor the data properly, the system may end up becoming an AI prediction model for something that you hadn't anticipated, and it would drift over time. And again, there are tools and techniques for managing those things, and managing accountability of AI models and the robustness of it. So I made 2 points at the beginning. One is that there is great opportunity now to tap into semi-structured and unstructured content with latest AI to enable automation, optimization, and decision support for business processes. And then I made the point that for AI to work in enterprises, we need to take not just about accuracy into account, but also all these other factors for which I gave a mnemonic called RACE facts. That is robustness, accountability, consistency, transparency, fairness, all these things. So last but not least, I go back to the quiz question and say, you know, you do all these things. How do you measure all these things? We know how to measure accuracy. How do we measure how robust, how accountable, how consistent my AI model is? Well, we got to get there. And, maturity models can be a good way to do there in a qualitative way to say, where am I in my AI journey? Do I have right set of processes for doing all of these things in terms of, am I managing the security? Am I managing the fairness of my data and such? You go through the qualitative questionnaire and understand where you fall in a scale of 1 to 5. So AI maturity models is a good way to start, but there are also additional maturity and fact sheets emerging in the field of AI. And all these things need to be brought to bear in order to really address this journey to AI, that is bringing an organization into infusing AI into enterprise. It's about having the clarity of purpose, understanding what it takes for AI to deliver value, and what data is required to be prepared to teach AI, what skills once you put in place are required, who needs to manage these on a regular basis, and what level of expectations are there for those people in order to manage these models. Because it's not like you just build it by an AI infused application and forget about it, right? It needs constant monitoring and management and such. So here are the frameworks that I covered today as part of the two assertions that I made. Of course, raise your facts, the mnemonic, AI maturity model, AI model continuous learning, the ability to be able to monitor and make sure that you are continuously improving the model, and this 3-layered model that says that, in order to really get to solve a particular problem in a business process with AI, you don't need to solve the broad AI problem. Use language models that you can build one on top of the other. So let me conclude there. I know I went through some of the later part of the content rather quickly, and that's a full talk by itself, actually, and some of those are available in public domain on YouTube and such. Let me pause here for opening it up for questions. So Kira, I'll hand it over to you.
Thank you, Rama. And I would now, there is already one question actually from Marlon. So Marlon, I will unmute you. You are allowed to talk now.
Yes, so thank you very much, Rama, for this very comprehensive,
Hi, Marlon. Yeah.
Very comprehensive, very insightful overview of the non-functional properties that we expect from AI technologies in order to infuse them into BPM. And there is something in your framework that I think is kind of maybe between the lines. It mentions explainability, but I feel that in the context of business processes, explainability is not enough. But it is great that one is able to explain predictions. Like I could say, like, I am predicting this customer will complain because they are between 20 and 35 years and they come from this region. But that does not help me to improve the business process. I would rather like actionability, that this person comes from this region and has this age, and therefore we should do this in order to minimize their probability of complaining. So where do you put this actionability in the framework, and have you given thought to how would you put it in a maturity framework, or how would you measure it?
Yeah, Marlon, thanks for asking that question. So, I would think of that actionability as one of the outputs that is expected of the AI model, right? Depending on how you frame your model in the business process. Let's take this again, the one that I've gone through today, the log anomaly, as an example. It's not just enough to say that there is an anomaly. You have to really be able to make it actionable to the user to say, okay, what do I need to do to fix it? So in our case, we broke it down as 2 different AI models. One AI model is predicting the log anomalies, which is giving you the signals, the insights. And the other AI model, which is the next best action recommendation AI model, is the one that actually takes the inputs of all the other ones, the insights, the signals and anomalies and such. And it is the one that is looking at data to make a recommendation on what action to take. So depending on your problem and domain, you split it up to say, but it's not that actionability, of course, is an important attribute of an AI model, but I see that as really, you frame that as an AI model in itself, and that model in itself now needs to be explainable. Why are you telling me that I should take this action, right? So that's how I think about it.
Okay.
Okay, so there is another question from Ingo. So Ingo, just a sec. Let me see if I'm able to unmute you. Yeah, you can now talk.
Yes, thanks also from my side, Rama. Very interesting talk, especially for me as well, because we did quite a bit of work on dependability and operations. One thing that you were talking about was runbooks for automating the response to understanding a problem. And we actually did some work where we used AI planning to that end, right? So this requires knowing the current state of the system, the desired state of the system, and having a model for the actions. And in that work, we could do that because we used AWS, and they have a well-defined API, and we, created a AI planning model of that domain of the actions, and we could sense what the state was. Mm-hmm. And we could understand what it should be, and therefore we could plan which actions should be taken for recovery. Do you think this is applicable to settings in which you're working?
Absolutely. In fact, yeah, this is one of the things that we are experimenting in our labs as well, very much so. And you're absolutely right that first of all, there is the derivation of the runbook, right, before you can run the runbook. So that how do you derive that these are the set of actions that need to be taken, and that this is the sequence of actions that need to be taken in this order. And that is really like, exactly, it's a planning problem, and depending on where you are. And I've given one example in the talk, which was deriving that sequence, the temporal sequence, right? And that you can get it from the context, from mining the unstructured data with NLP. And applying AI planning is another way to do it. And in fact, it's probably needs to be a combination of these two, in really framing the problem as this is the goal and this is where you are currently are, and figure out how you get there. And there may be multiple steps that you have to take, and depending on the specific environment, different subscripts need to be applied in order to achieve that particular outcome. So AI planning, I see, can play a critical role in that, deriving that runbook in order to automate the execution of it.
Great, thanks.
So there is another question from Sheila. I will allow you to talk, but please try to use the Q&A feature of Zoom and not the chat if you want to ask questions.
Hi, hello. Can you
Hello.
hear me?
Yes.
Thank you for your great presentation. I was thinking that maybe, what do you think about process meta modeling? Do you think that it could help to explain how IA works? I mean, I don't know. It was just more a question that.
Yeah, absolutely. And thank you for bringing that up, because I didn't get a chance to talk about it. So one of the things that I mentioned here is, measuring, in this particular example that I've talked about today, measuring the mean time to metrics, right? These are in a process that is the incident resolution process. The metrics are mean time to detect, mean time to identify, mean time to resolve, and so on. Now, that is actually, how do you measure those things? When we go to a particular company, we should be able to say, give me all your data currently of how your IT operations folks, SREs, manage your process. And we should be able to either manually construct the cycle times, that how many minutes it takes, how many hours it takes for each step for diagnosis, from the time an alert comes to fixing and so on. So we need to be able to construct that. Now, if those process activities and the data associated with them are available, we should be able to actually do process mining on that to automatically extract those metrics, the mean time to measure all of these metrics from process mining of the before and after processes. And we should be able to demonstrate the value that after we applied AI, we redid that and we were able to improve. So process mining plays a critical role in actually in measuring the important metrics, and also in identifying further opportunities for improvements, right? If still certain aspects, say diagnosis, is the bottleneck, or after diagnosis, the actual, or after identifying that there is a problem, the fault localization step is the most time consuming one. So if you look at the cycle times at regular intervals, after every iteration, even with AI, there might be several opportunities in the process, in the way systems and humans are working together, workflow is working. There might be opportunities that will be revealed when we look at those mined processes. So I see process mining playing a critical role in helping observe the quality of the AI infused business process, and also in helping guide where further opportunities exist for either infusing AI or for optimizing with workflow or human involvement once we deploy an AI infused process. So yeah,
Thank you,
thanks for
thank you.
asking that question. That's
Yes, I was thinking more in that, because I think meta model could explain better how IA process, like for structuring and help the knowledge workers or the people involved within the process.
right.
Thank you very much.
Right. Yeah, thank you for asking that.
Okay, so I think we have time for a last question. There is one from Amin Jalali. I will allow you to talk. And you
Yes.
can
Thank you very much, Rama, for nice presentation. I have a question. I have heard from different data scientists from different companies that life was easier before these privacy concerns come into enforcement, like GDPR and other regulations that we have. With more aspects like fairness and others, how do you see the future? Because currently they are like recommendation, but it's expected that they also come into enforcement. How do you see the future of applying AI in organizations when they come into enforcement?
Yeah, that's why it is accountability is absolutely critical. The auditability, because auditability is a requirement, no longer an optional thing to have. The governance of data is here to stay, and genuine concerns around the privacy associated with the data need to be addressed in preparing data for AI, and that is a critical part of it. And what that means is it actually opens up opportunity for more AI. So if you look at organizations that sometimes have concerns where they say my data cannot go out of my environment, even within the departments within the same company, they cannot let you take the data out to a particular cluster to train. So that's where federated training and federated learning techniques are emerging, right? Which allow you to train these models where data sits where it sits, and you train it, and what eventually gets in your hand is really the trained model, and that's the model that you deploy. So you cannot trace back to the original data with which it's trained, which means that you cannot trace it back to the names or mentions of people's private information. And so with AI, we can now also address some of those type of GDPR concerns. And again, with the combination of this federated learning and good hygiene with provenance and capturing the disciplined way in which you train the models, prepare the data, you version the data sets, and you version the models and keep the lineage of which data set was fed into which model, and what were the test results associated with it and all that. When you keep that provenance with the accountability in a tool, and there are many platforms that support that provenance creation, and add to that this using federated learning type of techniques, which allow you to keep the data private and secure in the environment, and still be able to train with that data and use the models. Of course, it's not perfect. It limits what you can do when you don't have full access to the original data for retraining and incremental training purposes, but it is still doable. And it is, there are, depending on the use case and depending on the amount of regulatory monitoring that's needed in a particular environment, I have seen companies leverage these techniques, federated learning techniques, to build AI models as well.
Good, thank you.
So I think time is up, and we should all thank Rama and give her at least virtual big round of applause for the talk. Thank you again. And I will now, before let's say reminding you about the next steps, leave the floor to Manuel for a second.
Yes, thank you. Well, thank you, Rama, for your talk.
My
yes,
pleasure.
Because as you remember from the opening, we were going to play the videos from Sevilla in every research session, including the keynotes, and we forgot to do it before. So, Adela, please, can you?
Sure. I can stop sharing my screen. Yeah.
Yeah, it's a way.
Would have loved to be there in person to see the beautiful city of Sevilla, but
yeah,
I will make do with the video.
Can you see my screen?
Yes.
Yes.
Okay.
We're standing in front of the Plaza de España, which is a huge square and a half circle of buildings which is built around it. It's built in 1928. It was built at the time for the huge Ibero-Spanish exhibition that took place at the time in Sevilla. It has a mix of styles which, yeah, in a very beautiful way blend together. There was Spanish Baroque, Renaissance, and also a new interpretation of the Mudéjar style, which you can see all around here. And it's quite impressive if you stand here. What you can also experience here is that in the semicircle, the architect built an alcove for each of the 50 provinces of Spain. And since I'm really in love with Spain, for me it's a fun thing to walk around and look at all the provinces that I've already visited. And it also reminds me of the many places I still need to see here in Spain.
Also here, the Plaza de España was used as a background for some movies. For instance, Lawrence of Arabia in 1962, and of course, the second episode of Star Wars in 2002. Actually, recently I was watching this movie with my children, and they were so surprised that they could recognize the Plaza de España, something so close to them in that movie. So yeah, it was really an experience for them. And also something interesting here is that many families come with their children to make a small boat trip around the canal. And that's something that children also enjoy a lot. I came here with my children when they were younger, and we did that. And we have nice memories from that. Thank you.
Oh, we missed all that.
Yeah. So thank you, Adela, and thank you, Rama, again. And the social virtual event of BPM starts in almost 10 minutes, something less than 10 minutes. It won't be possibly as, I don't know, exciting as the real one, or maybe yes, who knows? So we have to find out now. So thanks again, and thanks for coming, everybody, and Rama for giving this interesting, very interesting talk.
Thank you. It's been my pleasure. Thanks for having me. Bye.
Bye.